Hello, my name is Mike Korshinov, and today we are going to talk about telemetry. It's existed on the market for 3 years, and we will start with a brief introduction. We'll take a look at the components. What current state is it right now? And as a final thought, just to have a whole picture about telemetry right now. Telemetry is an automated process for gathering data from remote or inaccessible points and transmitting this data to receiving equipment for monitoring or for some analytics. In case of streaming telemetry, we want few quantities of it, and it should be fast, easy, reliable. Data for it should be useful, deterministic because we want to know what and where to expect, and as much as possible data. So that's the motto which we have when we design streaming telemetry for our routers. If we start to compare streaming telemetry to SNMP, we can see on the top left graph that we can stream much more counters, and we can do it much faster with streaming telemetry because this concept was designed from this, in the system. And in terms of CPU load, we add receivers, and with 3 receivers, we have 8% of CPU consumption compared to 20% CPU consumption in SNMP. So we can easily see that telemetry brings us a benefit in terms of CPU load. And of course, we can stream much more data, and we can do it faster. So time to collect tons of counters with streaming telemetry over SNMP is just like a wonderful advantage. So key takeaway from this moment is we can get our collection faster, we reduce load on CPU, and we can do more counters. Telemetry existed on the market for 3 years, and in my opinion, it's going to early majority, and early majority is pretty good to be, or in majority as well. Here I will need a small help from auditorium. Do you consider using like telemetry in sandbox or some lab environment, or just like consider to using? If so, please raise your hand to have an overview. Okay. So we have some attendance. Do you use telemetry in production in your network? Oh, okay. Okay. So something in early adopters or early majority, probably we are moving into early majority piece over here. And it's good to be in majority. We don't want to be in laggards, but we slowly start to adopt this technology. When it was designed initially, the first and main goal was to replace SNMP because of clear disadvantages of technology and how long it exists on the market. First and initial focus for replacement. When you can add, you can remove the CLI execution on the device, like show comments, and you want to get this data in automated and like programmatic way. And doesn't matter if it's like control plane or data plane. This is the first aspects which we had in mind. Once you start to advance and bring more features on the telemetry side, you can think about not only cadence-based events, like streaming counters out of device, but add something on top of it, like syslog messages, which is event-based telemetry, or have more hardware data and stream your NPU stats from the device. And of course, we are not limited in future implementations to do something else, like in band telemetry, S-Flow, NetFlow, or add some support for OpenBMP. So this is like still considerations, and there is a room for improvement for telemetry. Let's proceed with components. And once we talk about models, we have 2 approaches over here. You can select native models, and this would be your superset of models. It's like 201 package. You will have it. You'll have everything in it. Perfect for each use case. But it may be not that portable for your transportation, or you don't always want to bring it with you, it's not very versatile, because if you go to different vendors, you have different modules, and with such variety of different models, you need to do some work on top of it. It can be just normalization, or you need post-processing for your data. So you name it. If we took open config modules, it's standard for across the vendors, but the coverage much smaller, and the graphical representation is nice because it's on only a small set of screwdrivers, but probably it will solve most of your cases. And if it doesn't do it, you just go for native modules, and that approach is perfectly fine. But once you start to consider open config modules, here you need to be very precise in what exactly you stream out of device. Bunch of young models published on GitHub, it's available, and you go through this model and identify a revision name. Across different vendors, you may have different support for revisions. Plus, you need to keep in mind revision for your operation system version, because different revisions, small variances and nuances in implementation for open config module, you may have some difference. So you need to make sure that you check everything before you start to build some analytics on top of it. Revisions is not the only one aspect. You also need to make sure, to be sure about deviations, because different deviations may exist for different vendors, and you better to check on a public source how it's implemented for this specific deviation. So yes, it's open config model. It's perfectly match for, I don't know, 90% of the same items, or maybe more. But some things still may be different. So we need to make sure of it. A lot of activity around IETF standards, and it's good to have standard body in this scenario. And we are looking for what's going on around, and keep this in mind for future deployments and future enhancements. We discussed models. We have open config modules, which is your limited set of screwdrivers, or native modules with 200 items in the list. And after we're going for encoding, you have 3 types of encodings. First one is GPB, or Google Protobuf. We also call it compact GPB, and we're going to touch base on that. Next one is key-value GPB, or self-describing GPB, which is still Google Protobuf. And the third is JSON. I don't think it doesn't need explanation over here, and it's very well known and very human-friendly. Transport, 3 methods here. gRPC, it's Google RPC, and when we have just traditional our methods for connections, TCP and UDP. If we talk about gRPC, it comes with overhead, and your connection before your data going out of a device, it's negotiated. And you can see in the Wireshark that HTTP magic numbers send some details and settings sent from the router. Also, negotiation going for window size from both sides. And only after settings confirmation, you have to stream your data. A little bit overhead, but it comes with an advantage, because speed control available from the collector side, and it can be window could be adjusted based on the collector decision, and that's good. gRPC is a modern protocol, and we saw more and more utilization in network world for it. TCP and UDP are very well known in the industry. It exists for a long time, and when you start to consume your data in TCP or UDP, you may be aware, you should be aware of the header. And once you start to build your own collector, just keep this header in mind that before processing the data itself or the payload, you need to strip the header for further processing. Another aspect of transmitting data is security. With gRPC deal-in mode, when you initiate connection from the collector side to the router, two options available: no TLS or TLS. In case of sandbox environment or just lab trials, you don't want to generate certificate and just want to check the capabilities, what exactly exists. It's good to use no TLS option. And the disadvantage of it, all your sensitive data is sent in a plain text. Of course, this solution shouldn't be applicable for your production deployment or real-life scenarios, and TLS should be utilized. So man in the middle will be not able to decode your message. Is it enough to claim that gRPC supported for your transport protocol? Well, some nuances here exist as well. If we talk about different implementation from different vendors, you may see that your RPC is described, but methods inside have different signatures. And once you start to build your collector, or you want to have more in-depth knowledge of what's inside and how it's organized, you need to check how it's implemented internally, because this is crucial. Different type of messages can be sent, various data structures, and overall, it's good to be aware of implementation. So you may have heard the claim that gRPC is supported, but again, there are still nuances. We touch base on the transport, and let's go through encodings. The first encoding is most efficient one. It's Google Protobuf Compact. Everything in this encoding is binary, and that's why it's extremely efficient. But per each model, you need a protofile. And this tooling is required in order to decode your message. Also, protofiles may be different for different versions of operation system. So you may consider to use key-value GPB or self-describing. String represents your key, and your value still binary. It's easier to consume. You have medium wire efficiency with key-value GPB, and you need only one single protofile to decode your message. And this is the compromise which used across many customers, because it's easier to start with key-value, just one protofile. You do not have much of data yet collected from telemetry, and you are good to go with key-value GPB. Maybe you don't care about Google Protobuf, or you just don't want to invest time in learning how it works internally and what it feels like to deal with GPB. Go ahead, use JSON. Everything is string in this case, keys and values. You have the lowest wire efficiency in terms of JSON, but it brings you benefits in terms of consumption. You can stream your data directly to Kafka or to any other receiver. It's very human-friendly, it's readable, you can validate it directly in Python. And this is a good start for some of the beginning trials with telemetry. For XR-based devices, they don't care which encoding you select. Think about predefined seats in a train. It's not first come, first serve basis. Your seat already reserved to you. And once the model is processing with encoding, we know all the types of, for each entry, for each field. So encoding is fast for any type of available options. So you just don't care about it. You care about wire efficiency. And once we proceed with numbers, we same send a message. With GPB, it would be 300 bytes, key value GPB 1100, and JSON 1300. Key value, as I mentioned, could be a good start for you to explore telemetry. But what do people really want? In terms of transport, gRPC is most advanced. On the second place, we'll go TCP, and that's bring us reliability. And you probably, if you're running on some legacy systems, you will have only UDP option. With UDP, you may miss some collections because of the protocol instability. And if you have some problems in your network, UDP may be not the best option. So if you have this capability to stream over gRPC, go for it. Encodings, key value GPB is your first start. Single protofile, no need for a bunch of protofiles like in compact GPB. And of course, no one limits you to use JSON. But expect to have less wire efficiency. And once we proceed with modules, OpenConfig, of course, the first one, because of the higher adoption. Native modules have supersets of features, but we do not forget about IETF, and people still see interest in it. You can start explore telemetry today. It's already available on the boxes. It exists. It's proven, and some collection stack based on open source tools available for you. Cisco released Pipeline, which is open source collector, and it's first stop for your data. Once your data in Pipeline, you can stream it to any source. It could be influx data, which is time series database, perfectly fits for telemetry data. It could be a Prometheus stack with all required components, or you can just consume it to Kafka and create a bunch of subscribers for your bus. Well, if you use JSON, you may just go directly to Kafka and to avoid using pipeline. But again, all these tools are fully available, and you can try to install them today and already run trials in the lab. It's worth to mention visualization tool, and usually we use Grafana to demonstrate how it works, because it's open source. The community around Grafana is developing new feature pretty rapid, and also they have alerting mechanism. Besides the visualization and monitoring for all your data, you can configure thresholds and send webhooks to any of your agents or some business logic which you may have behind the consuming telemetry. It's open. Go for it, give it a try, and proceed with it. We have more upcoming features, and recently we announced support for gNMI. gNMI, it's initiative led by OpenConfig, and it's network management interface defined by OpenConfig, because they are main contributor behind it. It's data model independent. It relies on gRPC framework for communication and rich tooling available for it. The main idea for gNMI to provide a standard approach for encoding and transport and across different vendors. And once more and more vendors will support gNMI, you may have unify encoding just across different OpenConfig models, which will bring you versatility and will simplify your operations in terms of processing your data. gNMI should be the answer for you. You have 4 types of RPC, main RPCs. One is to get capabilities from device. Another one is get, set. And we are interested in the last RPC, subscribe, because it's utilized by telemetry. Once you define the message, you have list of preselected type, and you just need to construct your message further. So gNMI is here, and we expect to have more adoption in terms of usage for gNMI. What's the main use case for telemetry as of now? The first you can start easily is to replace SNMP. Probably you have a bunch of SNMP pulled out of your device, and you can see the benefits by replacing them to model-driven telemetry. We have published a bunch of use cases where you can monitor your routing protocols, interface stats, all your node health, and a bunch of details related to it. When you start to collect this data, you may want to conduct some types of analytics on top of it. And here you may bring some third-party knowledge to build this analytics insight for it. And because more and more data generated in your environment, you may start to use some patterns for analyzing and just proceed with statistics on it. Different companies announced support for streaming telemetry, and we can see more and more of them catching up on streaming telemetry. Because previously it was just SNMP based, and now they support streaming telemetry as a part of their package. And as a closing reminder, we need to have a full picture in our head. At first, you have young models, each used for configuration and operation models for your device. It allows you to simplify the dealing with CLI and replace it to a more programmatic approach. When we touched base on gNMI, it relies on protobuf because we mentioned GPB and gRPC as well as a part of it. And this is a management protocol. The third component is gNOI, and this is network operation interface. It's mostly used for operational commands. And last but not least, it's gRibai, which gives you interface for RIB and allow you to programmatically access based on API. And once you consider to have all these components in mind, you can see that protobuf utilized in 3 of them, plus gRPC is heavily used. So if you don't yet spend your time on learning how internally protobuf works or gRPC, it's good to go for examples right now and just spend some time learning on it or give it a try. Configure gRPC directly on your box if it's supported, and just to have an idea of where this direction is moving to. And that's all for today from my side, and I'm open to questions.
Hi, Tony Tauber, Comcast. Good presentation and overview, and we're starting to get wet with this, which is exciting, and people have questions. I can maybe share a little of our experience. What I'd say is third-party tool vendors who want to do analytics and discovery and all this kind of thing, you need to start supporting this. Like this, coming to us and saying, okay, man, we're just going to set up, just give us SNMP access, because that's what we need to figure out what your network is. They need to start supporting telemetry, facts discovered by telemetry. Usually they don't need traffic stats. Even if they do, they should be able to accept them in some other format, CSV or whatever, an extract. If they need topology, interface information, entity information, get it from telemetry. Figure out some way to subscribe to the Kafka bus or whatever to get that information. That's what I'd have to say. Thanks.
Yeah, thank you. You can just configure a separate Kafka instance directly for them and provide secure channel for third party to access this data. Of course, so
Yeah, it's just their compatibility that needs to be
Yeah.
there.
Thank you.
Hi, Stefan von Denik. We started with telemetry around a couple of months ago because of the need of SNMP isn't providing all the data, all the metrics anymore, which telemetry at the moment does. For example, MAC accounting, which is pretty nice to have when you are connected to an IXP environment. And so the thing is, from a roadmap point of view, can we say that telemetry is the future of exporting metrics and SNMP is going to die? Because currently it looks like that SNMP is already lagging metrics, which you can still get via CLI or via the telemetry thing.
Yeah, few nanogs ago, it was presentation led by Google that SNMP is dead. Well, it's still somewhere in the field, but we drive towards telemetry, and this is future for exporting metrics.
The other, what really costed me a lot of time was the thing to find out that I guess the old stuff was policy-driven export, and now as the state-of-the-art Cisco thingy is model-driven, right? So you can forget about policy stuff. So this was the first thing I stepped into. I started with the policy thingy, and I thought, no, this is not working out. So I'm solving a different puzzle here. So this was really confusing, and you should get rid of on the website with it, because people still Google it, the policy stuff, and I think it's deprecated, right?
Yeah, so the main naming for it is streaming telemetry, which includes module-driven telemetry. And we have cadence-based for like interface and all of that based on a sample interval. And we support event-driven telemetry, for example, for syslogs.
One last question. When we jump over from metrics to configuration, starting with iOS XR 6 something, we try to get to deploy the whole router configuration via netconf-yang, and we have plenty of cases open with you guys because we were able to crash the whole system. So Cisco basically wasn't able to do the adjustments for the basic stuff. For example, if you push also the management configuration and the layer 2 configuration and so on, at some point it crashed the whole system. So with the new approach, does Cisco guarantee that I'm able to push the whole configuration and the system is doing all the adjustments without, in the best case, without any service impact? Or
well, in case for telemetry, it's just like pushed data out of the device. And as it was demonstrated on one slide, once you add more receivers, it's still stable. So for netconf, I hope those issues would be resolved.
Is netconf and gNMI or the other thing, are two different approaches, or?
Yeah, it's kind of different. We can discuss that
later on. Oh, thank you very much.
Thank you.
Paul. Doesn't work.
I'll speak while he's waiting for microphone. Jafaz Juniper. SNMP bibs are dead. Don't expect new things to happen with those anymore. Telemetry transport is a distraction. We have a lot of flavors of things on the screens in front of us. They all do roughly the same thing as far as you're concerned for getting state out of your network. That's great. Choose whatever happens to work for you. That said, the thing that everybody in this room should be doing, and I'm saying this as a vendor, demand standardized models. You want to be able to get your state out of the network without having to go through some vendor augmentation to get something that's important. The thing that MIBS really gave you was the ability to get the same stuff from different platforms. Demand standardized models.
Yep, that's a good comment. Thank you.
Yeah, Paolo Lucente, NTT Communications. Do you work for Cisco?
Yeah.
Oh, okay. Somehow I was thinking you were working for Google. So I am three plus years later. I see the picture you want me to have in mind, and I see too many 3-4 laterals starting with G. So a little bit of follow-up from what Jeff was saying, like standardized models. What I missed in this presentation is maybe a little bit of a sense where streaming telemetry is going in terms of standardization and interoperability, with vendors. It's true that the two routers don't have to stream telemetry to each other, But if I build a collector, myself, I find that I have essentially to build multiple collectors, one per vendor, and that is simply unacceptable. And it's simply just not working out, 3+ years later.
Thank you. I think we are going to address those exact issue with gNMI support.
Steve Ulrich, Arista Networks. 2 comments. One, wholehearted agreement with Jeff in terms of demand for standards-driven models. One thing that it hit me, you might point out in the future is, the complement in Yang to the deviation is the augment. So from a standards perspective, you can start with standards-based models and ask your vendors to provide the associated augmentations for the nibbly bits that are not necessarily found in your cast of screwdrivers there. I was wondering if you could perhaps provide a bit of commentary or some thoughts around model versioning and handling of various model versions across vendor implementations. I think as an industry, we're not talking about some of the inherent operational complexity associated with managing different versions of models inside of software revisions, across software versions, or even across vendors.
Unfortunately, I think right now it's kind of manual process to manage because you need to validate your current release of operation system for your vendor, plus supported open config version for a specific model. And just like to have this track in one Excel spreadsheet.
Yeah, I think we have a new combinatorial problem that we can look forward to future NANOG presentations to debate.
Thank you. Yeah, last question.
Alyssa Cooper, I'm the chair of the IETF, and I work at Cisco as well. This is a comment, actually not a question for you, but just to follow up on the comments about standardization. If there are things that the IETF models are not giving people that they need, or things about the IETF process that aren't giving people what they need in terms of the speed of standardization or anything else about it, I would love to hear more about that and get new ideas for how we can more effectively produce standardized models that get take up in the industry. So please come talk to me if that's something that interests you. Thanks.
Thank you.